simple stuff, simultaneous equations. How many ways of solving simultaneous equations do you know? What are they? Elimination, right? These two. Is there one more that you know? Graph. Yes, graph. No one uses this to solve simultaneous equation, right? Because it's too troublesome. And these two methods are much easier, isn't it? Okay. So our topic, chapter 1.1, is on simultaneous equations. Does it sound difficult? No, it doesn't sound difficult. Now, for A Maths, my recommendation, we won't be using this to solve simultaneous equation. We've got two more options, substitution and elimination. Who prefers to use substitution? Raise your hand. Okay, who prefers elimination? Raise your hand. Yeah, usually it's like that, half-half, okay? My preference is to use substitution. But elimination has its merits too. Stop playing. Elimination has its merits too. Sometimes it is faster. Hey, is that Erwin? Stop playing, Ken. Okay, sometimes elimination is faster, but you don't really get to use elimination all the time. Therefore, substitution is my preferred method because it always is available and we can always use it. Okay, so let's go straight now into practice now 1 on page 5. Okay, so you can do it either in your textbook or on your foolscap paper. Practice now 1, question 1. Solve the simultaneous equation x plus 2y equals to 5, x squared minus 3y plus x equals to 9. Okay, everybody please stop working. I need you to follow the logic. It goes over there. Okay, so equation number 1, equation number 2. Suppose I want to eliminate. What do you think we should eliminate? Okay, eliminate y. Does it make sense to eliminate x? Think about it. Does it make sense to eliminate x? What happens if I choose to eliminate x from both of them? What am I left with? What are the unknowns I'm left with? If you eliminate x, what am I left with? I have x squared and I have y, isn't it? That doesn't help me at all. What if I choose to eliminate y? I eliminate the y over there, eliminate the y over here. What am I left with? X squared terms, x terms, and constants, right? Can we solve that? Yes. Yes, we can. Using our factorization, which you learn in lower sec. But, so that's the issue with elimination. You need to decide what to eliminate based on a question like this. What if we choose to use substitution? I can choose to either substitute x over here. I can choose to substitute y inside here. Both of them will work. Okay, so that is why it is my preferred method. So the working for solving simultaneous equation will always be very similar. Okay, and this is how I will do it. From equation number 1, do you want to make x the subject or y the subject? After you make either x or y the subject, you know you have to substitute it in, right? So let's think about it. Should you make x or y the subject? X. Okay, let's say we make x the subject. I'm going to get x equals to 5 minus 2y, isn't it? Then I've got 5 minus 2y. I need to substitute into the x squared, right? Do you need to expand it? Yes. Is it so just think about it. Eventually, if you make x the subject, I'm going to have 5 minus 2y squared. I need to expand. Then minus 3y plus 5 minus 2y equals to 9. Sounds like quite a bit of work to do. What if I choose to make y the subject? If I make y the subject, I will have 5 minus x divided by 2. I substitute one time inside here only, isn't it? Isn't that a bit easier? Yes. Okay, so make a decision. Either way, whichever way you choose, they will work. It's just that one way could be easier than the other. So instead of setting traps for yourself, you might as well choose the easier way. So from equation number 1, 2y equals to 5 minus x, y equals to 5 minus x over 2, sub into equation number 2. These portions that I'm going to highlight will always be standard. From equation number 1, make something the subject, sub into equation number 2. Next step. From equation number 2, I have x squared minus 3 times of 5 minus x over 2 plus x equals to 9. Okay? So now it's a solving. I see a fraction over there. I don't like the fraction. Can you give me a suggestion on what I should do with it? I don't like this 2 over here. How do I get rid of it? Everything times 2. Okay, let's multiply by 2 everywhere. So everything will stay the same, right? Because whatever I do on the left hand side, I do on the right hand side. So multiplying by 2, I get 2x squared minus 3, 5 minus x. If you can do this mentally, do it. Then you can skip a step. Plus 2x equals to 18. Is anybody lost at this point in time? Anybody lost? You must raise your hand, you must tell me. None, huh? Okay, so now I expand. 2x squared minus 15 plus 3x plus 2x minus 18 equals to 0. I bring everything to one side so that I have equal to 0. This is the next thing I must see. Yes?
Do you not put equal signs on the side?
Where? Over here?
Like between each step?
No. This is one equation. This is another equation. Are you suggesting that I should be writing equal signs over here?
No.
Are you suggesting that?
Isn't that how you do normally?
No? No? Yeah, one equal sign in one line. Okay, so from here, I will want to group all my like terms together. So I have 2x squared plus 5x minus 33 equals to 0. Right? Yes? Three times 5 minus x, why? You mean this 3 over here? I multiply by 5 to get negative 15. Then I multiply by negative x to get 3x. Why I don't need to multiply by 2? Okay, so are you saying that you are unsure how to get to this step? Yeah. Okay. So you are asking about from this step to get to this step. Okay, let me explain. So my goal is to get rid of this 2 over here. I want to get rid of this 2. So what I intend to do is to multiply throughout by 2. Left hand side I multiply by 2, right hand side I multiply by 2. So let's talk about the right hand side first. I multiply by 2 is 18, right? Easy, huh? Then on the left hand side, everything multiply by 2. Okay, so similarly over here I multiply by 2. Okay, now my 2, when I expand this out, when I expand the left hand side, 2 times x squared, I get 2x squared, yes? Okay, now 2 times of this, referring to this whole chunk, right? Let me write it down at the bottom so that it is clearer. I've got now 2 multiplied by negative 3 multiplied by 5 minus x over 2. Agree? Then the 2 and the 2 cancel. Okay? That's why at this step I asked whether anybody is lost already. Then you must tell me so that I don't need to go backwards again. Okay? So try and stay with me. So this is what I have. 2x squared plus 5x minus 33 equals to 0. Can we solve this? Can we solve this? How? How do you solve this type of question in lower sec?
Factorize.
Oh, factorize. Okay, what do we have? X minus 3. 2x plus 11, is it? Do you know how is this obtained? Let me do a check. Okay, so I've got 2x and x. Let's put a 11 and a 3 over here. So 2x squared, 33. Here I have 6x, 11x. I want to get 5x. So I must subtract over here. Okay? All familiar with this? You may be using another type of multiplication frame. But as long as you can show me this, you will get the mark. Can? Okay? So now that this is equal to 0, what then should I write next? What does it imply if this is equal to 0?
X equals 3.
Or,
X 11 over 2.
right? Do you know why or not? Or is it like your teachers have been telling you every time you see this, it means that x equals to 3 or x equals to negative 11 over 2? Do you know why? Does anybody know why? You know why? Okay, can you please share with the class? Jia Hao, right? Share, yes. Okay, so the first point, x minus 3 is 0. He is saying that x minus 3 is 0. Do you agree? Is that what I'm saying? X minus 3 is 0? I think some of you are starting to see that when you have something multiplied by something equals to 0. Right? We got something multiplied by something equals to 0. What does that imply about the somethings? One of it is 0. Does that make sense? The only way you're going to get something like something equals to 0 is that one of the somethings must be 0. Must it be one of them or it could be the other one? Either one must be 0, isn't it? That's why we say that there's a intermediate step. This implies, this symbol means therefore or so. Or this implies that. Something that something equals to 0. This implies that x minus 3 equals to 0 or 2x plus 11 equals to 0. Does this make sense to you? In order for the product to be equal to 0, must be either this or this equal to 0. Therefore, x equals to 0 or x equals to negative 11 over 2. Get it? Now, I've got my x values already. I still need my y value, right? So, I will sub back into my equation number 1. My equation number 1, over here I've got y equals to 5 minus x over 2. I've got my x value. So, therefore, y equals to 5 minus, this is 3. 5 minus 3 over 2 or y equals to 5 minus negative 11 over 2 over 2. Okay? This is clearly 1. Or y equals to 5 plus 11 over 2 is 21 over 2, 21 over 4. Correct? Is this the answer at the back? Okay, so now I've got my x and y values. I've got 2x values, I've got 2y values. How should I present my work? That's where the next question is important. State the coordinates of the points of intersection of the line and the curve. You should realize that x plus 2y equals to 5 is a line, a straight line, because you can change it to y equals mx plus c. And for the other one, it is quadratic. It has a power 2, so it is a curve. When these two graphs intersect, okay, whenever you have, for example, a graph intersecting with a line, these 2 points, they have coordinates. And these will be the solution. This is the x1 value. This is the y1 value. This will be our x2 value. This will be our y2 value. Okay? So the x has a corresponding y. Listen carefully. The x value has a corresponding y value. Look at your work. I've got one x value, one y value, another x value, another y value. Which x and y come in a pair? Are you able to tell? Which x and which y come in as a pair? As an ordered pair. 3 and 1 or 3 and 21 over 4? 3 and 1. Yes, because we substituted the 3 into to get the value of y. So these two, they form an ordered pair. Similarly, these two, they will form an ordered pair. So if I were to write down the coordinates of the intersection, I've got negative 11 over 2 as well as 21 over 4, and on the other side I've got 3 and 1. These are my coordinates. Any questions for simultaneous equation? Okay, then I do not need you to do, but you just take a look at question 2. Okay, find the coordinates, blah blah blah. This is how we'll start it. From equation number 1, do you want to make x or y the subject? Y. You want to make y the subject. In this case, it doesn't really make a difference because either x or y, you'll still have to expand it. So make y the subject equals 7 minus x, and the next part, sub into 2. So you must have named the equations beforehand. So we will get x squared plus x times y, 7 minus x, minus 2 times y squared, so 7 minus x squared equals to 10. Right, this is the substitution step. From here on, you just need to expand carefully. This one, you need to know how to expand it. Expand carefully, you're going to end up with something x squared plus something x plus something equal to 0. Okay, so these dotted parts means you do it yourself. You are expected to be able to do it. It is basic mathematics from lower set. We're going to end up with something like this. Ax squared plus bx plus c equals to 0. This means that you group all the x squared together, group all the x together, group all the unknown together, make sure you have equal to 0. Okay, take note that this a, b, and c can be positive or negative. Doesn't matter. I'm just writing plus b plus c. It can be a negative value. Okay, once you get this, you will then need to express it this way. Something equal to 0. Then you get x equals to something or something. Always the same. Therefore, y equals to something or something. This is the complete step. I want x, I don't want 1 over x. What should I do? Times x. One thing that you should know, fraction minus fraction. Whenever you see a fraction minus fraction, your instincts must kick in. Try to combine them. How do you deal with a fraction minus fraction? Primary school. What does your primary school maths tell you? Same denominator, 7y minus 12 over 12y. Right? Am I too fast? No, I think you can handle this. So this is 1 over x. Can you tell me what is x now? Can you tell me what's x now? Agree? Huh? Why? What's wrong? Why suddenly flip? Because this is 1 over x equals to another fraction. I want to flip my 1 over x to become x over 1. Then the other side also flip. That's a shortcut. Mathematically, what does it mean? This is 1 over x on one side. On the other side, I have another fraction. I can choose to cross multiply. And then after that, you divide again to make x the subject. That's another way of doing it. But once you realize that 1 over x equals to another fraction, all you need to do is to flip both sides in order to get the value, the expression for x. Okay? Once I have this, I can sub into equation number 2. Because I've got my x term already. Therefore, I will get 12y over 7y minus 12 times y equals to 12. Then just continue to solve normally. This you can solve using your lower sec maths. So what have we learned in this topic, A maths, the first topic? What have we learned? What do you mean by leceh? What you have learned, I would say, is a recap on substitution, the substitution method. But this time, I think you have learned how to choose what to make the subject, to make things easier for you. So plan a little ahead. Okay, that's all for exercise for topic 1.1.